We've all seen large language models do some pretty amazing things, right? Generating text, code, incredible stuff. But have you ever stopped to think about how often they actually reason their way through a tough problem, like really complex math or deep science questions? They often get stuck or sometimes make these logical leaps that just, well, they don't quite add up. It feels a bit like watching a really bright student who, sometimes skips a few crucial steps. So today we're doing a deep dive into a really fascinating paper. It's called ReasonFlux PRM, Trajectory-Aware PRMs for Long Chain of Thought Reasoning in LLMs. It's aiming to crack the code on making LLMs not just smarter, but genuinely wiser by teaching them to think more like an expert problem solver. Our mission here in this deep dive, it's all about understanding how we can level up these large language models, LLMs, so they can reason more effectively, more reliably, especially when they're facing really complex tasks. We'll unpack why the current ways of doing things sometimes fall a bit short, and how this new approach, ReasonFlux PRM, it offers a pretty significant leap forward. Think of this as your shortcut to getting up to speed on this really cutting-edge AI development.
Yeah, and this isn't just some academic curiosity. Improving how LLMs reason is absolutely critical, like fundamental for the future of AI in the real world. For all the impressive things they can do, getting them to not just spit out answers, but to genuinely think coherently, logically, constructing a process you can actually check. That's been a persistent challenge, and this paper tackles that head on. It pushes us closer to AI that doesn't just know what the answer is, but understands why it's the right answer.
Okay, right. So let's dig into that core idea. When LLMs tackle these really complex problems, they don't just magically produce the final answer, do they? The researchers talk about something called a thinking trajectory that happens before you get that polished final response. So this trajectory response output, it means you get two things. First, this long, detailed, sometimes kind of messy intermediate thinking process. You compared it earlier to seeing a chef's whole prep station, ingredients everywhere, maybe some spills, notes, all that before the perfect final dish.
Exactly. That's a great analogy. You see the whole journey. And then after all that exploration, you get the concise, step-by-step final response, the perfectly plated dish. But here's the really interesting part. While those thinking trajectories are incredibly rich, they show the LLM's actual thought process, the dead ends, the explorations, everything, the existing tools we have called process reward models, or PRMs. Well, they haven't really been able to use them properly. See, PRMs are basically AI models designed to supervise and check these intermediate steps. But historically, they've mostly been trained on and only evaluated those final polished responses.
Ah, okay.
Which leads to a big question. If we want LLMs to really reason better, shouldn't the PRMs be looking at the whole thinking process, not just the end result, supervising the messy trajectory too?
Right. It sounds like there was a fundamental mismatch there. So when researchers actually tried using those existing PRMs on the detailed thinking trajectories, what happened? What went wrong? Where did they hit that wall?
Precisely. They ran into two major problems, which really highlighted why a new approach was needed. The first issue is what the paper calls a structural and formatting mismatch. It's fundamental. Thinking trajectories just look different from neat final answers. Think about how you solve a hard problem out loud. You might start down one path, realize it's wrong, backtrack, maybe explore a couple of alternatives before landing on the solution.
Yeah, absolutely. Lots of trial and error.
LLMs do that too in their internal processing. So their trajectories can have branching, revisiting earlier steps, trying different angles, and they often have weaker global coherence, as the paper puts it, meaning you might see speculative thoughts, maybe some slightly disjointed logic.
Yeah.
Very different from the clean linear flow you expect in a final answer.
Okay, so it really is like trying to grade messy scratch paper using a checklist made only for the final typed up essay. The tool just doesn't fit the task. What was the second big challenge then?
Exactly that. And the second issue was, quite simply, a lack of specific training data. The existing PRMs just hadn't been trained on this specific kind of trajectory response data where you assign rewards or scores to each of those messy intermediate steps. They were only used to seeing the final product. They didn't have examples of how to evaluate the journey, the thinking process itself. It's like trying to teach a driving examiner by only showing them videos of perfectly parked cars. They miss evaluating all the driving that happened before parking.
Okay, and let's connect this back to you, our listener. Why does this training gap matter? Because the paper points out something pretty critical. If you just rely on these older PRMs to pick out what they think is good thinking data, you can actually make things worse for smaller LLMs trained on it. Their performance can degrade.
That's the crucial point.
It really is like trying to teach a student by only showing them the answers on the final exam without ever giving feedback on how they worked through the problems, including their mistakes and explorations. You miss that huge chance for real learning. And the student or the LLM doesn't actually get better at the core skill of reasoning. So it definitely sounds like we needed a totally new way of doing things, one that actually sees and evaluates the entire thinking process, warts and all, not just the final result. Is that where a ReasonFlux PRM fits in?
Precisely. That's exactly the gap ReasonFlux PRM was designed to fill. It's a novel, trajectory-aware PRM built specifically to understand and evaluate those complex, sometimes messy thinking trajectories, not just the final answers. And the core innovation, the really clever part, is that it uses both step-level and trajectory-level supervision. It looks at the details and the big picture.
Okay, dual approach. Let's break that down. How does it handle the step-level rewards? How does it score those individual messy steps?
Right, so for the step-level rewards, ReasonFlux PRM gets really granular. It assigns specific scores to each individual step within that thinking trajectory. And it does this by looking at 3 key things for every single step. First, there's an alignment score. This basically checks how similar a thinking step is semantically to a step in the known correct final response.
Ah, okay. To keep it on track.
Exactly. It penalizes things that are just made up hallucinations or stuff that's totally off topic, keeps the LLM focused. If it starts talking about, I don't know, pizza during a physics problem, the alignment score catches it. Second, there's a quality score that asks, does this step actually make logical sense right here in this context? For this, they use an expert model like GPT-4o to act as a judge.
Like an AI teaching assistant.
Sort of, yeah. It evaluates the correctness of that specific substep, its internal logic, and whether it's actually moving things forward towards the solution. It's checking for logical soundness at each point. And third, there's a coherence score. This looks at whether the current step fits logically with the previous step. It encourages that smooth flow and penalizes those weird, abrupt jumps in topic or logic that you sometimes see.
Great, keeps the chain of thought actually chained together.
Precisely. Make sure each link connects properly.
Wow, that is incredibly detailed, like having an expert looking over the LLM's shoulder for every single thought it has. But you also mentioned trajectory level rewards. How does that work? How does it evaluate the overall game plan?
Right, that's the higher level view, and it's quite smart. For trajectory level rewards, they again use an expert LLM like GPT-4o to look at the entire thinking process. And its job is to extract the core strategy, like a high-level reasoning template or a flowchart of the approach the first LLM used.
Okay, so like the underlying method.
Exactly, the strategic blueprint. Then here's the cool part. They take that extracted template and give it to a different AI model, and this second model tries to solve the original problem using only that template. The reward for the original LLM's whole trajectory is then based on how well those template-guided attempts worked. On average, did they get the right answer? So this really tests if the overall strategy was sound, if it was efficient, if it could work generally, not just if the individual steps happen to be okay. It's like judging a chess grandmaster's opening strategy, not just individual pawn moves.
Okay, so that's the aha moment. It's this combination, understanding the tiny details, the step-by-step logic, and the big picture strategy, the overall plan. That granular and holistic feedback is what was missing before. It lets ReasonFlux PRM actually nurture the entire problem-solving ability of an LLM.
It's exactly right. And connecting this back to the real world, ReasonFlux PRM isn't just some theoretical advance. It has very practical, very tangible applications that could really change how we develop and use LLMs. First up is offline data selection. This is huge. It's about finding the best quality training data to teach smaller LLMs how to reason. Normally, you either pick data randomly, which means lots of junk, or you pay humans a lot of money to carefully curate it. It's slow and expensive.
Right.
ReasonFlux PRM can automatically score and filter vast amounts of potential training data, picking out only the examples with the highest quality thinking trajectories. This is perfect for supervised fine-tuning, where you teach the LLM based on good examples. It saves a ton of effort and compute. Second big area, online reward modeling for reinforcement learning, or RL. This is where LLMs learn through trial and error, getting feedback as they go. ReasonFlux PRM can provide that feedback continuously, giving fine-grained rewards for each step the LLM takes while it's trying to solve a problem during training.
So real-time coaching.
Exactly. It guides the LLM towards better reasoning strategies much more effectively than just getting a simple right or wrong signal at the very end. And third, There's reward-guided best-of-n test time scaling. This is a common technique where you have an LLM generate several possible answers to a question.
To increase the chance of getting a good one.
Precisely. But how do you pick the best one out of, say, 5 or 10 options? ReasonFlux PRM can score the reasoning quality behind each potential answer and select the most logically sound one. This boosts performance when the model is actually being used at inference time without having to retrain the whole thing. It makes existing models smarter on the fly.
Okay, this is where it gets really impressive, the results. The paper shows that their model, ReasonFlux PRM 7B, could pick out better training data than even human-curated datasets, like one called S1K. And it outperformed much, much larger PRMs, too, like a 72 billion parameter model from Qwen. It's 10 times bigger.
Yeah, the size difference is remarkable.
For example, using data selected by ReasonFlux PRM led to a 6.0% gain on the TUF Match 500 benchmark and 6.1% on GPQA Diamond in fine-tuning tests. That's a noticeable improvement just from smarter data selection. And across the board, the gains were consistent. They report average improvements of about 12% in supervised fine-tuning, 4.5% in RL, and over 6% in that best-of-n test time scaling. But here's the bit that really jumped out at me about efficiency, getting better results with less data. They showed that training a smaller LLM on just 1,000 samples picked by ReasonFlux PRM 7B actually did better than training on nearly 60,000 raw, unfiltered trajectories.
That's a massive difference in data needs.
It really is. It means we could potentially build more effective reasoning models much faster and using way less computational power. That's a huge deal for AI development.
And they provide some really clear case studies. There's one example with an incorrect math solution generated by an LLM. ReasonFlux PRM was able to pinpoint the exact step where the logic went off the rails. It did this by assigning much lower step-level reward scores to that specific step and the ones that followed it.
So it flags the failure point.
Precisely. And conversely, when an LLM produced a correct solution, ReasonFlux PRM gave consistently high scores all the way through the thinking process. So it's not just about whether the final answer is right or wrong. It's about understanding how the model got there and critically being able to identify and potentially fix the specific points where the reasoning falters. It's like getting an X-ray into the AI's thinking.
So what we've really unpacked today with ReasonFlux PRM is it feels like a significant step forward in how we supervise the reasoning abilities of these complex LLMs. It's shifting the focus from just grading the final answer to validating and actually improving the entire process of reaching that answer. That feels key for making AI more reliable, more efficient, and maybe even more understandable.
Absolutely. This deep dive really underscores that understanding how an AI thinks the process, not just the output, is going to be critical if we want to build systems that are truly intelligent and, importantly, trustworthy. It also just highlights the sheer power of carefully designed training data and these more nuanced reward signals. It suggests the path forward isn't just about making models bigger and bigger, but making them better, more effective reasoners.
And as LLMs get woven more deeply into our daily lives, everything from, customer service bots to tools for scientific discovery, being able to ensure their reasoning is sound, maybe even transparent, that's only going to become more important. So here's a thought for you, the listener, to chew on. How might improving this internal thinking process of AI models impact fields beyond math and science? Could we see applications in generating more logically coherent creative writing? Or maybe using it for complex strategic planning? What about navigating tricky ethical dilemmas where the justification, the reasoning, is just as important as the final decision? We really hope this deep dive into ReasonFlux PRM has given you a clear picture of how researchers are pushing the frontiers of AI, trying to build models that don't just talk, but truly think, one intelligent, verifiable step at a time.